Our favorite kind of quadratic is when we are launching projectiles. So if a projectile is launched vertically upward from the ground with an initial velocity of 73.5 meters per second, then, neglecting air resistance, its height h in meters above the ground t seconds after projection is given by the formula h equals negative 4.9 t squared plus 73.5 t. After how many seconds to the nearest hundredth will the projectile be 100 meters above the ground? Now, sometimes I think it's helpful to think about what this looks like, right? If we are on the ground and we shoot something up in the air, we shoot it up in the air, and then it comes back down. So we have this piece, or this parabola graphing here, which is a quadratic graph. If we're looking at 100 meters, 100 meters might be here. And therefore, it's very possible that we have two answers for this. It's also possible that 100 meters is at the very top and maybe we only have one. So you have to pay attention to, the math of the question. The big part of this is 100 meters above the ground means that h is 100. So we say, okay, if 100 equals negative 4.9 t squared plus 73.5 t. Well, it's a quadratic, so we need to get this to equal 0. So I'm going to subtract 100 from both sides, and I get 0 equals negative 4.9 t squared plus 73.5 t minus 100. Now, I don't know about you, but I don't do very much factoring or anything like that when I have decimals, negative quadratic coefficient. So I'm going to just turn to my handy dandy quadratic formula. So with the quadratic formula, we have got t equals, because we don't have x here, so t equals negative 73.5, right, the opposite of b, plus or minus the square root of b squared, 73.5 squared, minus 4 times a, and don't forget a is negative, times c, which in this case is negative 100, all over 2a. Again, a is negative 4.9. Now, when we simplify inside the parentheses, so I did this in a couple of steps. So I have ended up with negative 73.5 plus or minus the square root of 5402.25. That's 73.5 squared. And then we're going to subtract 1960. That's the 4 times 4.9 times 100. And all of that is going to go over negative 9.8. All right, so as I get through this, after I subtract these two, I get 3,442.25. In my next step, I'm going to go ahead and get a decimal. So negative 73.5 plus or minus 58.67. So that comes out of the radical, all over negative 9.8. So again, we have to check both of these. So if I take negative 73.5 and I add 58.67 and then divide by negative 9.8. And that's going to give me roughly 1.51 seconds. And then we take negative 73.5 minus 58.67 divided by negative 9.8. These work because we have a negative in the numerator, we have a negative in the denominator, and as we know, two negatives makes a positive. So both 13.49 seconds and 1.51 seconds. So what that means is that the thing takes off, and at 1.51 seconds, it hits 100 meters, and then it keeps going up, turns around, comes back, and then at 13.49 seconds, it hits 100 meters again. So there's two different times because it hits once on the way up, once on the way down. Right, so that's part A. Pretty gnarly, but it works. All right, so now let's get to part B. Let's clear my drawings, and we'll move down so we can see this a little bit. All right, so how long will it take for the projectile to return to the ground? Now let's just recall, here's my equation, negative 4.9 t squared plus 73.5 t. So if it's returning to the ground, again, we shoot it off, it goes up, it hits 100 meters twice. But when it returns to the ground, the height is 0. Makes it a little bit nicer. We just go ahead and we plug 0 in for h. So negative 4.9 t squared plus 73.5 t. Now we already equal 0, so we're ready to solve this. You'll notice on the right-hand side, both of our terms have a t value. So I can factor out a t. So I get negative 4.9 t plus 73.5. Now, using our zero product property, we know that t equals 0. Well, yeah, that's at the start over here. We knew that already. And then we have negative 4.9 t plus 73.5 equals 0. So I'm going to subtract 73.5 from both sides. Then I'm going to divide both sides by negative 4.9. And it will re-hit the ground 15 seconds later. Which you knew it had to be more than 13.49 because 13.49 is when it hit 100 meters, right? So like it was still in the air at that point, so it had to be bigger than that. All right, I hope that made a little bit of sense, and yeah, have a good one.